Morning, guys. You are getting my screen and voice. Please confirm in chat box. Yes. Today we are going to start Docker and Kubernetes. Docker and Kubernetes. So far in DevOps we have learned so many tools, guys. What we have learned, guys, from beginning, what we have learned in DevOps. First we discussed about Maven. Second we discussed GitHub. Next we discussed about Jenkins. Next we discussed about SonarQube. Terraform, Ansible, all these tools we covered, guys. Maven we discussed, GitHub we discussed, Jenkins is discussed, SonarQube is discussed, Terraform, right, Ansible. All these things we discussed. Anyone we missed, guys? Am I covered all these things or not? Maven, GitHub, Jenkins, right, we discussed Tomcat also we discussed, guys. Maven, GitHub, Jenkins, SonarQube, Tomcat, Terraform, Ansible, all these tools we covered in DevOps, right? So among all these tools, whatever we discussed so far, which tool is important, guys? Jenkins is very important. Among all these tools, Jenkins is very important tool, guys. If you want to deploy the application in real time, right, Jenkins is mandatory, right? In Jenkins only we are going to create the pipeline, CI/CD pipeline we will create. Through that pipeline only we will deploy the application into the Kubernetes cluster, guys. Kubernetes we are going to deploy the application. Right, guys, Jenkins is mandatory, guys, among all these tools, right? The next important tool after Jenkins, the next important tool which we are going to discuss today, so that is Docker, guys. After Jenkins, the next Docker is very important. Why Docker is important, guys? Right, inside the Kubernetes, if you want to deploy the application, what we required, right, some containers are required, guys, right? Containers are required. How you will create those containers? Through Docker only we will create the containers. Through Docker we will create the containers, right? So whatever the containers you are creating by using Docker, right, we need to manage those containers. How you can manage those containers? By using Kubernetes we are going to manage the containers. Here, what is this Docker, guys? Docker is a containerization tool, guys. Docker is a containerization tool. What about this Kubernetes? Kubernetes is orchestration tool, guys. Docker is a containerization tool. Kubernetes is orchestration tool. Right? These two are very important, guys. Right? In some interviews, they are asking questions only on Kubernetes also. Only on Kubernetes they are asking the questions, guys, right? So some interviews they are asking only, they are focusing mainly on Kubernetes. So entire our course, which tool is very important and difficult in the sense Kubernetes. It is a little bit difficult and it is important concept in entire our course, guys. So you guys, more attention is required on this Kubernetes and Docker, right? So today we are going to start. See, guys, today I will give the course content what we are going to discuss in Docker and Kubernetes, guys. In Docker what I will discuss, in Kubernetes what I will discuss, I will give the brief idea, right? Before going to that, guys, from today onwards, how many days it will take to complete this Docker and Kubernetes? How many days it will take to complete Docker and Kubernetes? Most of the people are asking when course will get complete. Guys, if I want to complete Docker and Kubernetes quickly, I need support from you guys also. I need support from you guys also, guys. Already time 8 o'clock, people are joining at 8 o'clock. How can I complete quickly? See guys, if I want, see guys, I need to complete only Docker. I need 1 week time, guys. 1 week means 7 days, Monday to Sunday. Monday to Sunday, 7 days is required to complete Docker, guys. Right? If you guys give, right, Monday to Sunday, I can able to complete the Docker. Daily, how many hours, guys? Not 1 hour, guys. I need 2 hours of the time. Daily 2 hours is required, guys. In the middle, I can't able to stop the session, guys. Right? So when we are discussing Kubernetes important concept, Kubernetes components on all, right? So in the middle, if I want to complete it, is very difficult, guys. So that's why if I pick any topic in the Kubernetes, I need to finish it. Guys. So here to complete, right, to complete Docker, I need 1 week of the time. Daily 2 hours is required, guys. So you guys are ready for this? 7:30 to 9:30 or 7:45 to 9:45. If you guys are okay, I'm ready to take 2 hours daily, and I will try to finish it in 1 week of the time. Right, next, to complete the Kubernetes, 2 weeks time is required, guys. 2 weeks time is required. Daily 2 hours here also. Daily 2 hours required, guys. The 2 weeks of the time, guys. See, guys, once I wrote the content at here, definitely you guys will surprise. So that much huge content I am going to cover. In the Kubernetes, guys. Single question also won't miss from this content, guys. Any question they can ask in the interview. You guys are in a position to respond for that question. So that much huge content we are going to discuss in the Kubernetes. Right. Along with this Kubernetes, here I need to discuss some of the monitoring tools and real-time project. To discuss that project, in that project only I am going to integrate all the things, guys. I am going to integrate with Jenkins all the things, Maven, Sonar, right, Docker, Kubernetes, Nexus, all these things I need to integrate in one project, guys. So including monitoring tools and that project session, it will take 2 weeks of the time daily if I take 2 hours session, guys. See, today date is 23rd. By 31st I can able to finish the Docker, right? Before next month 15th, before 15th, like 13th or 14th, if I want to finish Docker and Kubernetes with the monitoring tools, Prometheus, Grafana, ELK stack, these are the monitoring tools we are going to cover in Docker Kubernetes only, guys. Why? Because in Kubernetes cluster only we need to install monitoring tools also. In Kubernetes cluster only we need to install Prometheus, Grafana, ELK stack, those monitoring tools also we need to install. So that's why including those monitoring tools also I need 2 weeks of the time. Are you guys ready for 2 hours? If I take daily 2 hours, right, including Sundays, guys, I'm not going to take any holiday until completing this course. Including Sundays, if I take daily 2 hours, I can able to complete the course by February 13th or 14th. I can able to complete this Docker and Kubernetes, whatever the Docker tools are there, Prometheus, Grafana, ELK stack, right, Nexus also I need to integrate it here only. All these things I can able to finish it in by February 13th or 14th, guys. What about other people? Poonam is ready for 7:32. Guys, Kubernetes are very, very interesting and little bit difficult, guys. Daily practice is required, guys. Right? If you guys know only Kubernetes also, you guys will get the job 100%. So that much important, guys, Kubernetes. Very, very important. You guys definitely will get the interest and you guys need to practice also daily. Okay? But sharp 7:30 you guys need to join. Fine, guys. So let me write the course content first. What we are going to discuss. Course content. Right. First Docker, guys. First Docker I will cover. In Docker, what I am going to discuss first. In Docker, right? What is Docker, guys? Docker is a containerization tool, right? What is Docker? What is Docker? So before going to discuss about Docker, right, I need to talk about what is containerization. Why? Because I'm saying Docker is a containerization tool. So before coming to Docker only, I need to tell what is containerization. What is containerization? Right? So now we have the containerization tools in the market. We are using these containerizations to deploy the application. To run the applications, we are using containerization tools, guys. Before containerization, what people use it to work? From beginning onwards, we have these containerization tools? No, guys. Right? Before containerization, people use it to work with virtualization. So we need to discuss about virtualization also. What is virtualization? First, we need to talk about what is virtualization, right? What limitations are there in virtualization, right? Why containerization came into the picture, right? What containerization tools are available? Docker is one of the containerization tool. Docker is one of the containerization tool we need to discuss first, right? So after this, I will explain about Docker architecture, how Docker will run. How Docker will run, the Docker architecture I will explain. Next, we need to install this Docker in our Linux machines, guys. We need to install the Docker in our Linux machine. So I'm going to show how to install the Docker in Linux machine. Docker installation in Linux machine. In Linux machine. Next, guys, if you want to work with this Docker, right, we need understand some commands, guys. Docker related commands are there, very important, those commands, guys, right? How to create the Docker file, how to run the Docker image, right? How to run the Docker container. These some important commands are there. We need to understand those commands. Docker commands I will give. Docker commands. Next, guys, after Docker commands, I'm going to talk about Docker images. Docker images, guys. Docker image is nothing but what, guys? One package kind of thing, guys. Right, one package. Right, we are developing one software application, guys. Right, to develop that application code, to develop that application, whatever the softwares you used, that softwares, to develop that application, what dependencies, what libraries you used, those dependencies, those libraries, that entire environment we are going to package as the image. What is image, guys? Image is nothing but a package, guys. Inside that, what it contains, right? Our application code is available. To develop that application, whatever the softwares you are using, that softwares are available, right? Whatever the environment variables we have, dependencies we use, everything we are going to package as a Docker image. Right here, we need to understand, right, what is Docker image. Right, what are the built-in images are available? So many built-in images are available, guys. Right, those images, and right, based on my project, I want to create my own image. I want to create my own image. How to create the Docker image, right? All those things, custom Docker image, how to create the Docker images, all those things we are going to learn at here. Docker images are very important. Okay, if you want to create a Docker images, what you should know? First, what you know, guys? I want to create Docker images. Right? If you want to create Docker image, first you should know how to write the custom Docker file. Very important interview question. Right? How to write the Docker file. How to write the Docker file, guys. Inside the Docker file, we will use some keywords, guys. Several keywords are available. We will use those keywords. What keywords you will use inside the Docker file? Docker file creation is very important. From that Docker file only we will create the Docker image. Right? If you execute this Docker image, container will start, guys. Docker file, Docker image, container. if you want to run your application as a container, first you should have the Docker image. From that Docker image only, by using this Docker image only, container will start. Right? If you want to build a Docker image, first you should have the Docker file, guys. So we need to understand what is the Docker file. What is a Docker file? How to create the custom Docker file you need to understand. Okay, fine. So you are creating the Docker images. You are creating the Docker images. From this Docker image only, we are going to start Docker container. Docker container we are going to start it here, guys. Right? Here, whatever the Docker images you are creating, where you are going to keep these images? Where you are going to keep these images, guys? In the registry. Docker registry, we are going to keep all the images. Docker registry. We have public registry, private registry, guys. We have public registry, private registry. Right? In our project specific images, whatever we have, only I need to give access only for my team members, only for my company people only can able to access those images. Such kind of images we need to keep in our private registry. Right? In every project in companies, they will provide one registry. We need to keep those images in that registry only. Only our company people, only our project people can able to access those images. Outside people can't able to access. But I want to give the access for outside people also. I don't have any problem. Outside people also can able to access my images. Then we need to keep the images in public registry. Right? We need to keep the images in public registry. As a public registry, what you are going to use? As a public registry, what you are going to use? We are going to use Docker Hub, guys. Like this. Hub.docker.com is there. If you go to here, this Docker Hub only we are going to use as the public registry. Right? So for our practicing purpose, we can take the images which are already available in the Docker Hub, and whatever the images you are creating, those images you can keep inside the Docker Hub also. Right? If you want to keep Docker images inside, if you want to upload your images inside the Docker Hub, you should have the account. You should have the account in Docker Hub. First, we need to create that account, guys. Sign in. Sign in. So guys, this is my account. This is my account. See guys, in my account, I have uploaded these images for previous batch. Maven application I have uploaded. 10 people downloaded my image. Maven web application I have uploaded. 19 members are downloaded this application. Right? Java web application I have uploaded. Right? 21 members are downloaded this image. Java web application, right? 3 people only downloaded. Spring Boot application, 7 people downloaded. See, whenever I have uploaded these images in the Docker Hub, anybody can able to access, anybody can able to download into their machines, and anybody can able to run as the containers these images. We have uploaded in the public registry. See, 10 people are accessed. I don't know who accessed this. 10 people. 19 people are accessed. I don't know. 21 people are accessed. 3 people are accessed. 7 people are accessed. Like this. Right? If you upload the images in the public registry, it is available for all, guys. Anybody can able to access. Right? Same like this, we need to create the Docker images inside this Maven app. What we have, guys? Your application code is there, servers are there. Right? To develop this application, whatever the dependencies you used, those dependencies, everything, right, we created as a package. Everything we created as a image. If I give this image to anyone, directly they can run as the container in their system. Again, they need to install the Java. Again, they don't need to install the Tomcat. Again, they don't need to install the corresponding database. Nothing, guys. Everything is available inside this package only. Directly they can take and they can run in their machine, guys. Understood? So like this, we need to create the images, guys. Custom images. These are the custom images which I have created. Right? After creating the images, we can upload these images into the public registry or private registry. Right? As a public registry, we are going to use Docker Hub. Right? Private registries means only our company people will use. Only our project team members can use, guys. Such kind of private registers also we can create. They will give, guys. When you are working in the project, they will give the private registry. There you can upload your project Docker images, guys. Okay, right. If you want to create these kind of images, first you should know how to write the Docker file. From the Docker file only we will build the Docker image, guys. How you will build the Docker image? From the Docker file only. First you should know how to write the Docker file. From there only we will build the Docker images. By using these Docker images we will run the containers. We will run the containers, guys. Okay. See guys, we need to understand Docker registry. In Docker registry, we have public registries, private registries are available. As a public registry, we are going to discuss Docker Hub, guys. We need to create the account, how to create the account in the Docker Hub, how to push the images into the Docker Hub, how to download the images from the Docker Hub. Everything we are going to discuss at here, guys. Next, guys, right? If you want to create the Docker images, first what you should know? Docker file. What is Docker file? And what are the important keywords are available in Docker file? Docker file keywords. Docker file keywords. So many keywords are available, guys. So many keywords are available. Not one or two, guys. Multiple keywords are available. We need to understand those keywords. Right? We need to understand all those keywords. What is the purpose of each and every keyword? We should know, guys. Right? We have from keyword, maintainer keyword, copy keyword, add keyword, run keyword, CMD keyword, entry point, environment, label, user, worker directory, expose, volume, like this. So many keywords are available. We need to use those keywords at the time of writing our Docker files. Right? What is the purpose of each and every keyword? You should understand. Then only you can able to use those keywords, guys. Okay, fine. Next, after understanding this Docker file and Docker keywords, I will show some applications, guys. How to Dockerize Java web application. Java web application I want to Dockerize. How to Dockerize Java web application. Java web application I want to Dockerize, guys. How to write the Docker file, right, for this Java web application. How to create the Docker image from this Docker file, right. How to run as a container, right. Complete, right, creating the Docker file for your application, creating the Docker image from that file, and run as a container. We are going to show for this, guys. How to Dockerize Java application. Next, how to Dockerize Spring Boot application. Right, Spring Boot application. How to Dockerize Spring Boot application. Next, how to Dockerize Python application. Python application. All these things we are going to understand, guys. Right? Right, how to Dockerize, how to create the Docker file, your Java application. Right, from that Docker file, how you will create the Docker image. From that Docker image, how you will start the container. Same way, how to create the Docker file for your Spring Boot application. From that Docker file, how you will create the Docker image. From that image, how you will run the container. How you will create the Docker file for Python application. From that file, how you will create the Docker image. From that Docker image, how you will run the container. Right, these three applications we are going to discuss. Right, so next to the important concept is Docker volumes. Docker volumes we are going to understand. What is this Docker volumes, guys? You guys know, most of the people already know. In AWS we have seen volumes concept, guys. In AWS we discussed the volumes concept, guys. Volume is nothing but what, guys? It is the persistent storage, guys. Docker volumes are used to persist the data generated by the Docker container. Running the Docker container means what, guys? Running your application, guys. Running the Docker container means inside the container your application is running. Your application is running, guys. People are accessing your application. Your application running means this application will generate some data or not. Your application is running in the container means your application will generate the data or not. Yes, whatever the data this application is generating, I want to store the data inside the volume. I want to store the data inside the volume. That's why we are going to take Docker volumes. I want to store in some storage device. Volume is nothing but what? One persistent storage device. Even tomorrow if you want to remove this container, If you want to delete this container, you can decouple that volume from the Docker container. You won't lose your data, guys. You won't lose your data. Whatever the data this application is generated, we are storing that data inside the Docker volumes. After that, you can decouple these volumes from your container. Even if you delete that container also, still your data is exist inside the volumes, guys. What is Docker volume? How to create the Docker volume? How to mount this Docker volume to the application or a container? All those things we are going to discuss. Right. So once this Docker volume is completed, so next we are going to talk about the Docker Compose. This is very important. Docker Compose is very important, guys. So what is Docker Compose, guys? What we are going to understand in this Docker Compose? See, guys, in real time, tomorrow once you guys are joined in the company, right? Most of the times, most of the people will work with microservices architecture based projects, guys. Right? Developers knows about what is microservices architecture, what is monolithic architecture. Right? Most of the people will work with microservices architecture based projects, guys. Right? So in microservices architecture, several APIs will be available, guys. Here, every API in a project, every API is one project, guys. Every API is one project, and every API we should run in a container. Understood, guys? Microservices architecture means what we are doing? We are going to create several APIs in the microservices architecture. Here, each API we will call it as one project. So each API we need to run in a container. Running multiple containers manually for all APIs, right? It is very difficult job, guys. If you want to run multiple containers, container is nothing but what? One project. In each container, one project is running. So now I have multiple APIs in my project. Each API I am considering as one project. So I want to run multiple containers, guys. I want to run multiple containers. If you want to run multiple containers manually, it is very difficult process, guys. So that's why to solve this problem, we are going with Compose concept, Docker Compose concept. Docker Compose, it is just a tool, guys. We will use this tool to manage multi-container based applications. In interview, in single word, if they ask what is Docker Compose means, what answer you guys need to give? Docker Compose is a tool which is used to manage multi-container based applications. Multi-container based applications. Understood, guys? Right, we will understand. We will understand, guys, what is Docker Compose. See, here we need to write. Here we need to write so many YML files, guys. Docker Compose YML files. We need to write it here, guys. We need to write Docker Compose YML files. Okay, and how to write those YML files and all, we will discuss it here, guys. Docker Compose is one of the very important topic, guys. Right, after completing Docker Compose, I'm going to talk about the Docker network. Right, Docker network, guys. See here, network is nothing but what, guys? Communication. Communication purpose network is required, guys. It all about the communication among the processes, guys. Docker networking enables a user to link a Docker container. See, guys. Right, I want to download the image, guys. I want to download some image from the Docker Hub. Right, without networking, how you can able to download the image from the Docker Hub? I want to push the image. How you can able to push? I want to run the container. How you can able to run the container without having network? So Docker network we will use for communication purpose among the processes. What is Docker network? Here we have several types of networks are available, guys. Right, here Docker network drivers, guys. We need to use those drivers, guys. Very important question. Right, here we have 5 types of drivers, guys. Those drivers also we need to understand. Bridge driver, host driver, none driver, overlay driver, McFarlane driver, like this. 5 types of drivers are there in networking. We need to understand those drivers. See, guys, right, what network will do? It will provide the communication channel between the processes, guys. Between the processes. How two processes will communicate each other? I have 2 containers are running. 2 containers are running. In both container, in each container, different applications are running, guys. Now I want to communicate 2 containers each other. two containers wants to communicate each other. If those two container wants to communicate each other, some network must be required. Which network you will use? Are you going to use the bridge network? Are you going to use the host network? Are you going to use the overlay network? Are you going to use the McLaren network? Which network you will use it here? So those things we need to discuss it here. Networking is very important concept, guys. Right, guys? Right, we will discuss about the Docker networking. Once the Docker network is completed, we are going to talk about Docker Swarm, guys. Last topic in Docker Swarm. Guys, I'm not going to spend much time on this Docker Swarm, guys. I will explain what is Docker Swarm, right? What is the purpose of this Docker Swarm? I will explain, guys. But I'm not going to spend much time on this Docker Swarm. Why? Because in companies, we won't use this Docker Swarm. Instead of Docker Swarm only, we are going with Kubernetes. Right, what Kubernetes is doing same activities this Docker Swarm also will do, guys. Docker Swarm also one containerized orchestration tool. Containerization orchestration tool, guys. Docker Swarm came from the Docker only. Docker Swarm came from the Docker only. Who is providing this Docker? Right, they only created their own tool, which is Docker Swarm as a orchestration tool, guys. Who is providing this Docker? That company only, right? That company only released one tool for orchestration purpose, that is the Docker Swarm. But here one problem is there with this Docker Swarm. If you go with the Docker Swarm, auto scaling is not available, guys. Auto scaling concept is not there. If you want multiple servers, if you want to decrease the number of servers, you need to do manually, guys. You need to do manually. How you can do manually in production? Okay, in your local dev environment, sit environment, you can do, but your application is in live. Your application running in live, guys. Amazon application is there in live. Suddenly they announced one offer, festival offer, guys. So huge traffic will come. Right, you will go to that production environment and you will increase the number of servers, guys. Can't. Once application went to the production environment, that is live, people can able to access. Suddenly traffic is increased. How you can able to auto scale it? How you can able to increase the servers? How you can able to decrease the servers? Based on the traffic, it should be happened automatically. Based on the traffic, it should be happened automatically, guys. But that auto scaling is not available. Auto scaling feature is not there in Docker Swarm. We need to do manually. If you want to increase the number of servers, we can do. If you want to decrease the number of servers, we can do. But that is the manual process in Docker Swarm. That in production environment, how we can do manually? It is not possible. So that's why we are going for Kubernetes concept. In Kubernetes, auto scaling is there, guys. We don't need to do manually. Auto scaling is available, right? It will take care of everything, right? So these are the concepts we are going to discuss in Docker, guys. Have a look into this. Guys, if you want to understand Kubernetes, first you guys need to understand Docker. Have a look into this. What is Docker? Have a look into this, guys. Very important tools we are going to start. Please concentrate, guys. And in market, Kubernetes certifications are there, guys. If you do those certifications, very demand, guys. Your resume will get more weightage. If you do those certification, only for Kubernetes certifications are available. So Kubernetes is that much important a tool. See, guys, what is virtualization? What is containerization? What is Docker? What is Docker architecture? And how to install the Docker in Linux machine? Docker commands, Docker images, Docker container, Docker registry, Docker hub, Docker file, Docker at the time of writing Docker file, what keywords we need to use, Docker file keywords, how to Dockerize the Java application, how to Dockerize the Spring Boot application, how to Dockerize the Python application, Docker volumes, Docker compose, Docker network, Docker swarm. To complete all these things, I need 14 to 15 hours, guys. So that's why I asked 7 days. Daily 2 hours, 7 days is required, guys, including Sunday. Have a look into this course content, guys. Docker content. I will give the Kubernetes content also. Here, whatever the content I'm going to give, if you go through that, you can write the certification, man. Right. Fine, guys. Next, after completing this Docker, I will start the Kubernetes, guys. Kubernetes. What we are going to discuss in Kubernetes. Right. First, what is Kubernetes? What is Kubernetes? Kubernetes is a orchestration tool. Orchestration tool, guys. Kubernetes is a orchestration tools. By using Docker, whatever the containers you are creating, we need to manage those containers. Right? To manage those containers in order properly, we need one orchestration tool. As a orchestration tool, we are going to learn Kubernetes. Kubernetes is a orchestration tool, guys. Right? What is Kubernetes? Next, Kubernetes features we are going to discuss. Kubernetes features. What features are there in Kubernetes? Right? Very important features are there, guys, in Kubernetes. We are going to discuss those Kubernetes features. Right? Automated scheduling, self-healing capability, right? Automatic rollouts, rollbacks, load balancing, right? Storage orchestration, right? Service discovery, like this. Several features are there. We are going to discuss all those features at here. Next, after features, we will talk about the difference between Docker Swarm and the Kubernetes. Guys, remember, Kubernetes is not alternative for the Docker. Kubernetes is not alternative for the Docker, guys. Kubernetes is alternate for Docker Swarm, guys. Not for Docker. Not for Docker. It is alternative for Docker Swarm. Kubernetes is alternative for Docker Swarm, not for Docker, guys. Even in Kubernetes also, we need to understand all these things. Instead of Docker Swarm, we are going to work with Kubernetes. That's it. Difference between Docker Swarm and Kubernetes. Next, Kubernetes architecture. Kubernetes architecture. This is very, 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 very important. If you want to understand the Kubernetes properly, first you need to understand the Kubernetes architecture, guys. It is very lengthy architecture, guys. So many components are there in that architecture. You need to understand everything. You need to understand each and every component. What is the purpose of each and every component? You need to understand. Then only you can able to understand remaining concepts, guys. In the Kubernetes architecture, we have several components are there. We need to discuss all those components, guys. What we have, API server is there. What is this API server? Next, here we have, right here we have etcd is there. Next we have scheduler is there. Next we have scheduler. Control manager is there. Controller manager is there. Next we have what is pod, we need to understand. Next we have kube proxy. Next we have kubelet. kubelet, kubeproxy, kubelet, right? Like this, several components are available in the architecture. We need to understand everything, guys. It is very important. Kubernetes architecture is very important. I'm going to spend it more than 2 hours, more than around 2 hours. I'm going to spend only on this architecture, guys. Each and every component I need to discuss. Each and every component I need to discuss. See, let me show the architecture, guys. Kubernetes architecture. See, guys, see how many components are there. We need to understand API server, scheduler, controller manager, etcd, what is pod, what is kubelet, what is kubeproxy. All these things we need to understand, guys. We need to create this cluster, guys. This is we will call it as cluster. This is a Kubernetes cluster, guys. We need to create this cluster. Right here, control plane is available, worker nodes are available. These worker nodes we need to attach with the controller. Right here, through kubectl, we will give our request to control plane. Control plane will distribute that work to worker nodes. In worker nodes only, actual execution will do, guys. Actual execution will happen in the worker nodes only. Who will give the task to worker nodes? Control plane. Right? How you will communicate with the control plane? Through kubectl. Through kubectl, we will communicate with the control plane. Whenever we have given the request through kubectl, that request will be received by the API server. API server will take that request and API server will store that request information inside the etcd. etcd is the database. Inside the etcd, API server will store the data. After that, scheduler will check, is there any pending things in the etcd? Scheduler will check. If anything is pending, scheduler will talk to kubelet. Hey kubelet, I want to schedule my pod. I want to schedule my pod. Right? Is the resources are available in your worker nodes? Please check. And kubelet will check any resources are available to schedule the pod. Kubelet will check. Who will communicate with the kubelet? Scheduler will communicate. Any resources are available, right? Control manager, through control manager, it will run those. It will run those pods, guys. Here, kubelet only. Kubelet is going to work as the agent to this worker node, guys. Kubelet is going to work as the agent to worker. This everything is managed by kubelet only in the worker node. Right? For prime ministers, for chief ministers, how they will maintain the personal secretaries. Everything will be managed by those personal secretaries only. Here also, kubelet is going to work as an agent for this worker node. Everything is managing by this worker node only. The kubelet only. Scheduler will talk to kubelet. Hey kubelet, your resources are waiting, available. See, kubelet will check Docker is available or not. Docker only need to create the container. Docker only need to create the container, guys. So it will check Docker engine is ready or not. Right here, any pods are khali or not. Inside the pods only our containers are running. Right? In Kubernetes, directly we can't able to run the container. But in Docker, we can able to run the containers directly. But in the Kubernetes, we can't able to run the containers directly. Right? We need to keep those containers inside one unit, one logical unit that is called as a pod. That is called as a pod, guys. We need to create the pods. How to create the pods and all those things we will discuss, guys. See, everything, each and every component we discussed, guys. What is kubectl? What is API server, scheduler, controller manager, etcd, containers, pods, Docker engine, kubelet, kubeproxy, everything we need to discuss in this architecture. Right? See, that architecture we will discuss it here, guys. That architecture we will discuss. See, API server, etcd, scheduler, controller manager, pod, kubeproxy, kubelet, all these things we need to discuss. Right? Once this architecture is clear, next we are going to see the setup, guys. This cluster we need to set up. How many ways this cluster we can set up? See, guys, if you want to set up only one node setup, single node setup, single worker node only available, single node setup if you want to do, we have Minikube is there, guys. We have Minikube is available. Through that Minikube, we can do the single node cluster setup. Minikube, guys. But in industry, we will create multi-nodes clusters only. We won't create single node clusters in real time, guys. In real time, we won't create single node clusters. Always we will go with the multi-node clusters only. So here I am going to show how to create the multi-node cluster manually. I want to create my own self-managed cluster. I want to create my own self-managed cluster. How you will create self-managed multi-node cluster, we are going to discuss it here, guys. We are going to discuss how to create self-managed multi-node cluster. For that, we are going to use Kubedium. Here we have Minikube, Kubedium. By using Minikube, we can create the single node cluster. But in the industry, always we will work with multi-node clusters only. So we need to understand how to create the multi-node clusters by using Kubedium. So I will show how to create the multi-node clusters by using Kubedium, guys. Kubernetes cluster self setup. Kubernetes cluster setup. Guys, this is not that much easy. Setup using so many commands you guys need to do here, guys. Right, Kubernetes cluster setup using Kubedium. Right, using Kubedium, guys. Right, here we are going to create multi-node cluster. Multi-node cluster. I'm not going to create single node cluster, guys. We won't create single node clusters in the companies. Always we will work with multi-node clusters only. So here by using Kubedium, I'm going to show how to create the multi-node clusters. Multi-node clusters, I'm going to show it here, guys. Right? Kubernetes cluster setup using Kubedium, guys. It is very difficult, guys. Right? So many commands you guys need to run, guys. So many commands you guys need to run it here. But in the companies also you guys will create clusters using Kubedium. No, guys, no, we won't create, guys. It is the companies cloud providing clusters are available. We will use those cloud clusters only. The companies, we will use cloud provider clusters, guys. Suppose right, in AWS we have EKS is available, Elastic Kubernetes Service. By using that we can work. Right? You don't need to create this cluster, guys. You don't need to create this cluster. By using AWS, we can create. Everything will be managed by AWS only. Everything will be managed by AWS only. We no need to worry. Suppose if you are going to work with Azure, AKS is there, guys. Azure Kubernetes Service. You will use that Azure Kubernetes Service in Azure, guys. AKS. In AWS, EKS is there. In Azure, AKS is there, guys. Suppose if you go to GCP, Google Cloud Platform, there we have GKE, Google Kubernetes Engine. GKE, Google Kubernetes Engine is there. By using that, we can manage. Suppose if you go with IBM Cloud, there IKE is there, guys. IBM Kubernetes Engine, IKE. IBM Kubernetes Engine is there. By using that, we can manage, guys. But before going to, here I am going to discuss EKS, guys. AWS Kubernetes Service I will discuss. Before going to that, and I am going to practice with the Kubernetes cluster setup. Everything, our entire Kubernetes concepts, we are going to do this self-managed cluster only. But at the end, finally, right, so here whatever we did, everything we will do on application we will do in the right EKS also, guys. That EKS are chargeable, guys. If I start beginning only, if I start that EKS beginning only, within 2 weeks of the time, minimum to minimum, by the time of completing the course, minimum to minimum, I need to pay $500. $500 bill will generate, guys. I used only 1 week, guys. For 1 week, $160 bill got generated for me. Right, that EKS, guys. In EKS, everything is chargeable. Worker nodes are chargeable. Why? Because there we need to take large instances we need to take. Right? So that EKS, everything, that EKS is chargeable, and whatever the worker nodes we will create, those are chargeable. Everything is chargeable only. So we need to take care of that. Once you created this cluster, right, it will running, guys. Keep on, it will running until you deleting that cluster. So, but we can't able to delete in the middle, right? We need to keep that entire course. We need to keep that one until completing our course. If you keep 15 days or 1 week or 1 month, right, lot of bill will generate for that. Companies will manage, guys. Companies, they can able to manage. But here, that's why everything first initially we are going to practice with the self-managed cluster. For the self-managed clusters, bill got generated that much, guys. Right? Understood, guys? Later, all these things we will do in EKS also. case also, but there I no need to explain all these things guys. Topics wise we are covering it here only, all the topics. They're just we are going to I will show how to run the applications in the EKS cluster guys. Concepts are same, just the clusters we are changing, that's it guys. Okay, right. So after this Kubernetes cluster setup using Kubedium, I'm going to discuss components guys. What are the core components are available in Kubernetes? Kubernetes core components. What are the Kubernetes core components are available? Here we have so many core components are there. We will discuss those components guys. Whatever the core components are available, we will discuss it here guys. Right. Next, we will talk about what is namespace. What is namespace in Kubernetes, and how to create custom namespace. How to create custom namespace. What is namespace and how to create custom namespace in the Kubernetes we are going to discuss. Right guys, namespace is nothing but what guys? Suppose if you go to Java, in Java we have the packages guys. In Java we have the Java packages are available. In that packages only we are going to keep everything, right? The data access layers, service layers, right? Util packages, controller packages, like that we have several packages are available guys. Inside that package only, right, we will keep all interfaces, classes and everything guys. Here also namespace is nothing but what guys? Namespace represent cluster inside the another cluster. Namespace is nothing but cluster inside another cluster. Kubernetes components will be grouped logically using this namespace guys. Tomorrow I want to create the pod. I will create the pod inside one namespace. I want to create one service. I will create that service inside the namespace guys. Here Kubernetes components, pods are the Kubernetes components, right? Service is Kubernetes component. Whatever the Kubernetes components are there, those Kubernetes components, it will be grouped logically inside a namespace guys. Using namespaces, we are going to group Kubernetes components. So here some default namespaces are available guys. 3 to 4 default namespaces are available, right? And whenever you install Kubernetes, right, those namespaces you will get guys. Right? And you need to create, if you want to create a custom namespace, you can create, and your components, your application related stuff, you can able to keep inside the custom namespace also. What is the namespace? How to create the custom namespace? We will discuss it here guys. Okay, so after namespaces are clear, right, we are going to discuss about very main thing. What is pod? What is pod guys? What is pod? Pods are very important. Inside the pods only our application containers are running. Pod is one logical unit where we will keep all the containers guys. Inside the pod only we are going to run our containers. It is one logical unit guys. Right, in Kubernetes, right, like Docker, we can't able to run the containers directly guys. We can't able to run the Docker images directly as containers. We need pods. Inside the pods only containers will start. Inside the pod containers will start. Pod is nothing but a logical unit guys. Here we will discuss what is pod, how to create the pod, if any pod got crashed or deleted, right, how to recreate, right, another pod in that location, how everything we will discuss guys. Automatically it should recreate. Automatically it should recreate guys. Any pod got crashed or deleted, automatically one new pod will be recreate in that location. How it will do, right? For recreating new pods, what services, what we need to use, all those things we will discuss it here guys. Okay, fine guys. Here pods we are going to create, right? Manually we can create the pod, right? By using Kubernetes components also we can create the pod guys. If you create the pod manually, right, if whatever the pod you are creating, if that pod got collapsed, crashed, in that place another pod won't create. It won't create the another pod in that location. You are creating manually guys. If it is collapsed, who will recreate the pod in that location? That's why we need to go with Kubernetes providing components. If you create a pod by using Kubernetes providing component, right, if any pod got collapsed, if any pod got deleted, automatically Kubernetes will recreate another pod in that location. Kubernetes will recreate guys. Whatever the pod got deleted, same pod it will recreate in that location. But if you create manual pod guys, Manually, if you create the pod, it won't recreate, guys. But that's why we need to go for Kubernetes components. We need to create the pods by using Kubernetes components, guys. Very, 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 very important question. Right. See here in the right there, we have replication controller is there, replica set is there, demand set is there, deployments is there, like that. Several Kubernetes components are there. By using those components, we need to create the pods, guys. Interview compulsory question, guys. What is the difference between replication controller and replica set? What is the difference between replica set and demand set? Like that they will ask us. What is service component? What is the main purpose of service? Why we need to go for service? What is the difference between pod and service? What is pod? What is service? Guys, each and everything important only in interview. I told recently, 1.5 hours they asked me only on Kubernetes, guys. HSBC, they asked me 1.5 hours only on Kubernetes. Client people, guys. Not Indians, foreigners, guys. 4 members. In that panel, 4 members are there. All 4 members they asked only on Kubernetes, guys. Very, very important. Each and every topic is important only. Why? Because we are using Kubernetes for production deployment, guys. For live deployment, we are using Kubernetes. So each and everything is important only at here. Right. So next, guys. At here I am going to show what is pod. After that, I will discuss how to run our application in Kubernetes, guys. How to run our application in Kubernetes. How to run our application in Kubernetes. Next, how to create the pod. How to create the pod. Next, pod lifecycle. Pod lifecycle we are going to discuss, guys. What are the different processes are there in the pod lifecycle? Everything we will discuss, guys. Next, guys, if you want to create the pods, right, we need to write YML files. That's why I told beginning only in Ansible sessions only. YMLs are very, 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 very important, guys. Here everything in YMLs only we need to write. Manifest files. Pods we need to create using YMLs only. Services we need to create by using YMLs only. Everything is YML files only at here. So here I'm going to discuss pod manifest files. How to create pod manifest files. Pod manifest files creation. How to write the pod manifest files. Next, guys, what is Kubernetes service? See, guys, if you create pod, guys, you can able to access this pod within your cluster only. Within your cluster only we can able to access the pod. Pod means what, guys? Inside the pod containers are there. Inside the pod only our applications are running, guys. Right? Inside the pod only our applications are running. See, guys, if you see the diagram, see, pod is available. Inside the pod containers are running. Inside the container, each container is one application. And each container is one application. Inside the pod you can run any number of containers. See, container 1 means what? One application is running inside the pod. Right? If you want access this pod, we can access these pods within the cluster only. This is the cluster, guys. Master node, worker nodes, the combination of all 3 is one cluster. So like this, you can create any number of worker nodes, guys. You can create any number of worker nodes. Right? The entire architecture, master node, worker nodes, all these things, we will call it as cluster. Right? Here, pod we can access within the cluster only. Pod we can access within the cluster only. Tomorrow, once your application is deployed in the production environment, people should access from outside the cluster. I'm accessing ICICI Bank application from my laptop, from my home. Right? Are you within the cluster, outside of the cluster? Outside of the cluster, guys. If you want to access the application from outside of the cluster, from browser I need to access. How you can able to access? We need to expose these pods within the cluster and outside the cluster also. We need to expose the pods outside of the cluster. How you can able to expose the pods outside of the cluster? To expose the pods outside of the cluster, we are going for services concept. Kubernetes services are available. By using those services, we are going to expose the pods to outside of the cluster. Your application, we need to access from outside. From browser, I need to access. So, compulsory, you should expose your pods to outside of the cluster. And further, we are going to discuss services. Here, three types of services are available. Very, very, very important, guys. Services. Compulsory question in the interview. And here, when they ask what is services, how you can able to expose your application outside of the cluster means you need to talk about the services concept. We have three types of services. Cluster IP is there, node port is there, load balancer is there. If you go with cluster IP service, how it will work? If you go with the node port service, how it will work? If you go with load balancer service, how you will work? You need to explain in detail, guys. Guys, don't worry. Everything I will show practically. Everything I will show practically, guys. Right? So next, guys, after this Kubernetes service, we are going to discuss how to write this service related manifest files. Service manifest files. And for creating the services also, we need to write YML files only. And that's why how to write the service related manifest files. Right? Next, here we are going to discuss, I told right, Kubernetes components, replication controller, replication controller. Next, replication set, replication set. Next, daemon set. Next, daemon set. Next, deployment. All these things I will use at the time of creating the pod, guys. I want to create the pod by using replication controller. I want to create the pod by using replica set, guys. Replica set. I want to create the pod by using replica set. I want to create the pod by using daemon set. I want to create the pod by using deployment. Right? So all these things we will discuss. If you use a pod, that is the manual creation, guys. But if you create manually, what it will happen? Recreation is not available. Right? If pod got deleted, right, in that place another pod can't be recreated, guys. So that's why we need to create the pods by using these things, guys. Replication controller, replica set, daemon set, guys. In HSBC interview, they asked me what is the difference between replica set and daemon set. Right? And they asked me what is services. What is services, they asked. And they asked me at the time of writing Docker file, what is the base image you will take. Right, to take the base image, which keyword we need to use, right? So all these things they asked me, guys. Okay, right. Next, guys, after deployment, we are going to discuss deployment strategy. This is the common question, guys. Deployment strategy. The strategy you guys will follow at the time of deploying your application into the production environment. Which strategy you guys will follow at the time of deploying the application in production environment? This is the common question, guys. Without this question, there is no interview. Which deployment strategy you guys will follow at the time of deploying application? We have multiple strategies are there, guys. Right? One is recreate strategy. Next one is rolling update strategy. Right? Next one, guys, this is not a strategy, guys, but people are calling like that, but this is not a strategy, guys. This is one approach, guys. This is one approach, guys. This is not a strategy, but people are calling it strategy, but this is not a strategy, guys. Right? Compulsory question, this one compulsory question, guys. Right? Blue-green deployment, blue-green approach. Right? Blue-green approach, guys. This is the very important, guys. Right? In my project, we are using this blue-green approach only. Blue-green, guys. And most of the projects, they will use this blue-green approach only. Right? If you want to deploy the project in the Kubernetes cluster, which approach you are following, which strategy you are following? I'm following blue-green deployment. Blue-green deployment, I'm following at the time of deploying my application in production environment. This is very common interview question. They will ask, what is blue-green deployment? What is blue-green deployment, guys? Most of the companies will follow that blue-green deployment only. I will show, guys, how to do that. I will discuss, guys. Okay. Next, guys. After this, right, auto scaling, guys. Kubernetes auto scaling. In Kubernetes. This is because of this feature only we came to Kubernetes, right? Auto scaling. In Docker Swarm, we don't have this feature. Right? In Kubernetes, we have this feature. So that's why we are going with Kubernetes for auto scaling only. Right? So now after completing this all these topics, now I will install, right, AWS EKS, guys. AWS EKS. Again, I no need to discuss what is pod, what is service, what is replication controller, what is replica set. All these things we learned and we practiced also in our self-managed cluster. Directly, I will run everything in this EKS cluster, guys. That's it. Only I'm changing the cluster. I'm changing the cluster. That's it, guys. Instead of manually created cluster, just I'm using EKS providing cluster, guys. Concepts are same. Process is same. Just I'm changing the cluster, guys. Just I'm changing the cluster. Now I will go with AWS EKS. Right? I will show how to create the EKS cluster in AWS, guys. How to EKS cluster creation. EKS cluster creation in AWS. EKS cluster creation in AWS. Next, guys. Next. This is also in HSBC. This question also they asked me. Kubernetes ingress. Kubernetes ingress. What is this Kubernetes ingress? Ingress, guys. Kubernetes ingress, guys. See, guys. I have given facebook.com. That is my domain name. I have given to the public that facebook.com. All the people will send the request to that facebook.com only. In my Kubernetes cluster, multiple services are running. In Kubernetes cluster, multiple services are running. Now, whenever the people are sending the request to facebook.com, I want to map those URLs, whatever the URLs are there, that request URLs, I want to map with the service URLs. I want to map with the service URLs which are running in the Kubernetes cluster. Right? Means outside URLs, I want to map with the service URLs which are running in the Kubernetes cluster. Inside the Kubernetes cluster, multiple services are running. Inside the Kubernetes, multiple services are running. Each service will have some URL, right? Now, what I want to do outside URLs means people will send the request to our domain name. That is one URL. So, those URLs I want to map with service URLs which are running in the Kubernetes cluster. To map the outside URLs, external URLs with our service URLs, we are going to use Kubernetes ingress concept. What is the purpose of Kubernetes ingress? Map external URLs to our service URLs which are running in the Kubernetes cluster. We are going with Kubernetes ingress. This is one network type, guys. Ingress network. Ingress network is one network, guys. They will ask what is ingress network. Ingress network, guys, we will use to map external URLs with our service URLs which are running in the Kubernetes cluster. Right? So next, guys, next we will discuss. This is also very, very important question. This question also they asked me in HSBC. Right? Kubernetes Helm, guys. Helm. What is Kubernetes Helm? See, guys, in our Linux daily we are using. Right? If you want to install any package, if you want to install any software in Linux, what we are using, guys? We are using yum package manager. APT. Suppose if you are using Ubuntu based Linux machine, we are using APT package manager, like that, guys. yum package manager, APT package manager we are using. Same way, in Kubernetes also, we have one package manager which is called Helm package manager. Right? Helm is a Kubernetes package manager. By using this Helm package manager, we are going to deploy the applications. We are going to deploy the softwares in the Kubernetes cluster. You no need to write manifest files and all, guys. You no need to write manifest files and all. Suppose, right, I want ingress network. My system, I want ingress network, guys. Ingress is already available. So that ingress, by using Helm, you can deploy in your Kubernetes cluster. Right, in your Kubernetes cluster, you need ingress, guys. How you will get it? You need to deploy that application. Right. Instead of doing the deployment manually, I will tell to Helm package manager. yum install Jenkins -y. How we are doing same way, I will tell to Helm package manager. Helm package manager will deploy this ingress application inside the Kubernetes cluster. Right? In Linux, how we have package managers, apt yum. Same way, in Kubernetes, we have the Helm package manager. Right? So we will discuss this Helm package manager. Right, after completing this help map package manager, right, we are going to discuss monitoring tools, Kubernetes monitoring tools, guys. Kubernetes monitoring tools, guys. Kubernetes monitoring tools we need to discuss. What monitoring tools are available in Kubernetes? One is Prometheus. Prometheus is available. Next one is Grafana. Grafana is available. Right. So multiple questions they asked me on this, guys. Right. The very tricky questions. They try to confuse me. Right. Prometheus, Grafana, right, and ELK stack. ELK stack. So these three are the monitoring tools which we are going to use, guys. Some companies instead of ELK stack they will use Splunk, guys. Instead of ELK stack, some people will use Splunk also. Guys. Some people will use ELK, some people will use Splunk, guys. But that Splunk is a licensed one. Splunk is a licensed one, guys. If your project have more budget, then they will go with Splunk, guys. If your project have less budget, they will go with open source things. ELK is the open source. We no need to pay anything for the ELK. Some companies will use ELK, some companies will use Splunk. Splunk is the licensor, commercial, guys. We need to pay the money for Splunk, but ELK we no need to pay anything, guys. Okay, Prometheus, Grafana, ELK stash, these three are the monitoring tools, right? See, by using Prometheus and Grafana, we can monitor our Kubernetes cluster, how cluster is running, and how our worker nodes are running, and how pods are running. Everything we can able to monitor by using Prometheus and Grafana. Prometheus and Grafana is a cluster monitoring tools. Guys. Prometheus will collect the data from the cluster and it will store the data. Grafana will show visualization. Grafana is one web application, guys. Grafana is a web application. It will web application and analyzing tool, guys. Grafana is analyzing tool and web application. What it will do, whatever the data is collected by Prometheus, Grafana will analyze that data. And it will show you on the browser. That's why I'm saying Grafana is web application tool. That's why Grafana is analyzing tool and visualization tool also. Visualization tool means it will show everything in the graphical representations, charts, graphical representation it will show, guys. Prometheus and Grafana is cluster monitoring tools. Prometheus will collect the data and store the data. Grafana will analyze the data which is collected by Prometheus and it will show that data in the right UI, guys. Web application on the UI it will show, guys. Right. So they will ask. In interview they asked me, I want to monitor my Spring Boot application logs. They asked me, I want to monitor my Spring Boot application logs. Right. Is it possible to do by using Prometheus and Grafana? No, guys. So by using these two things, I am not monitoring any application logs. Guys. Just I am monitoring cluster logs, guys. How clusters are running. How worker nodes are working. How kubelet is working. How kubeproxy is working. That cluster I am monitoring, guys, by using Prometheus and Grafana. But if you want to monitor the application logs, how your Spring Boot application is running, how your microservices is running, then we need to go for ELK stack. ELK stack we need to discuss, guys. ELK. ELK means what? The combination of ELK stands for the combination of three main open sources, guys. Combination of three open sources. E means Elasticsearch. E stands for Elasticsearch, guys. What about that L, guys? Logstash. E stands for Elasticsearch. L stands for Logstash. K stands for Kibana. Guys. How Grafana is working at here, same way in ELK, Kibana will work, guys. Kibana is also one web application. It will show everything on the browser, guys. Kibana also one web application, right? Everything it will show, guys. Elasticsearch. It is used to store the logs, guys. Elasticsearch we will use to store the logs. Right, this Logstash we will use to process that logs, guys. Whatever the logs this Elasticsearch is storing, that logs we need to analyze, that logs we need to process. For that we are going with Logstash. Right, to display that logs, to show that logs, we are going to use Kibana. Kibana is a web application. ELK, Grafana, Prometheus. These three are the monitoring tools which we are going to discuss. These three are the monitoring tools which we are going to discuss, guys. Okay. And after that, here we will discuss stateless, stateful sets, stateful sets. Here only I need to write. Here I didn't wrote. Right, replication controller, replica set, daemon set, deployment. Right, here only I need to cover stateful sets also. Stateful sets also I need to cover it here, guys. With this monitoring tools, our course is completed. See, guys, how much content we are discussing in Kubernetes. If you go through this content, if you practice all these things, you guys can answer any question in the interview. Very huge content in depth we are trying to understand in the Kubernetes, guys. Okay. Just I have given high level also. What each concept, what it will do. What is Kubernetes? Right, different, right? See, guys, architecture, what API server will do, etcd, scheduler, pod, kube proxy, kubelet, right? Cluster setup in, right? Kubedium, why we will use Kubedium, why we will use Minikube, right? Core components, what we have, this control, replication controller, replica set, all these things are the core components only. What is namespace? How to create the custom namespace? What is pod? What is pod? Why we are using pods in the Kubernetes? How to run our application in Kubernetes? Because by using pod only we will run the application. That's why after pod I am giving explanation about this, how to run our application. Right? Then only you will get to understand what is pod. Right, next, guys, I want to create the pods. How to create the pods? Pod lifecycle, how pod will execute. Pod manifest files, we need to write the YML files. What is Kubernetes service? To expose these pods outside of the cluster, we need to go with services concepts. What is Kubernetes service? How many types of services are available? Right, what is the difference between cluster IP, node port, load balancing? Next, service manifest files, guys. Replication controller. See how you will create the pod by using replication controller. How you will create the pod by using replica set. How you will create the pod by using daemon set, deployment and deployment strategies. Right, in real time, which approach you will follow to deploy your application in the production environment. Blue-green deployment, most of the companies will follow. Next, how you will do the auto scaling in Kubernetes. EKS, guys, Elastic Kubernetes Service. Right, how to work with EKS in AWS. Right, EKS cluster creation we are discussing. Next, Kubernetes Ingress, Kubernetes Helm, Kubernetes monitoring tools. Everything we are going to see practically, guys. Is it clear what we are going to discuss? Guys, if you guys give daily 2 hours, if you guys are joined sharp 7:30 to 9:30, right, I can able to complete these things, all these things within 3 weeks of the time, guys. Within 3 weeks, including Sundays also. Don't ask half on Sunday, guys. I will take Sundays also. Right, I will try to finish it in before 15th only. I will finish, guys. Before February 15th only, I will finish. Okay. Okay, guys. Here only I will discuss Nexus concept also. Here only I will discuss. Right, here only I will cover Nexus also. What is Nexus repository also I will cover it here. Okay, guys. Very huge content we are going to understand in Docker and Kubernetes. Any question you guys can answer in the interview if you guys are clear about all these topics. Okay, guys. From tomorrow, we will start our Docker. I will start first what is virtualization, what is containerization, what is Docker architecture. I will try to finish all these things in tomorrow's session, guys. Okay. Guys, more attention is required from tomorrow. Daily practice is required, guys. Daily practice is required. So these two are the main tools in our entire course. After Jenkins, these two are the main tools, guys. Jenkins, Docker and Kubernetes. These three are the very, very important tools in our entire course. Anyone have any questions content wise? You guys have got the clarity what we are going to discuss next 3 weeks. Good. Fine, guys. With this, I'm stopping. Right, from tomorrow, we will start our discussion about the Docker, guys. Okay. Thank you, guys. Tomorrow, guys, sharp 7:30. Sharp 7:30. You guys need to join. Okay. Thank you, guys. Guys, you are watching in YouTube. If anybody wants to attend for this course, Docker and Kubernetes, right? If anybody wants to attend for this Docker and Kubernetes course, right? Please contact with this number, guys. Please contact with this number. 1 minute, I will give the number, guys. Please contact here. At the end, I'm going to give the number, guys. Nine 63 63 62 34 63 62 34 5870. So you guys can drop a message to this number. You guys can drop a message to this number, guys, in WhatsApp. Right. So we are going to discuss very in detail, in depth, guys. In depth, we are going to discuss in Kubernetes, guys. Right. If anybody have the interest to attend for this Docker and Kubernetes session, right, so please drop a message to this number, guys. Right. So what is the process? We will tell. Drop one WhatsApp message to this number. Right. We will discuss the process, guys. Okay. From tomorrow onwards, the classes are not going to come in YouTube live, guys. Only for today as a demo session, I have given the live. From tomorrow onwards, if anybody wants to join, right, they need to enroll for this. They need to enroll, guys. It is 3 weeks course, guys. 3 weeks we are going to discuss this entire Docker and Kubernetes. If anybody have the interest, please contact with this number, guys. Thank you, guys.